Okay, so yesterday we looked at this. And we discussed what a radian is. So 1 radian is the angle that makes the arc length to be equal to the radius, right? So you may ask, you have an arc length. This is equal to that. What you have here is 1 radian. A radian is basically a ratio between the arc length and what? And the radius. And you are calculating S over R. Simple stuff, discussed how that works. Then we went on to describe this angular displacement, which is in radians. The unit for angular displacement should be in radians. It is the angle. It can be in degrees, but we prefer to use radians. The reason is that radians are easy to convert to a straight line movement. Instead of using degrees will give us a lot of weight if we are to convert to a straight line movement. Radians are easy because if it's a straight line movement, you just calculate theta times the radius, you get a straight line movement. Okay? So we said angular displacement, it is the angle in radians made at the reference point by a circular movement. You move from this point A, you walk through that, you reach point B. The angle you have made here at the reference point, that is your angular displacement. Every time you make a circular movement, whether it's an arc or a full circle or many circles, there's always a reference point for a circle. At that point, what you are making is angular displacement. The angles you are making at the center, that is your angular displacement. In other words, just a measurement of angles that you have made. Yeah, I'm showing you in the wrong side. I pushed them that side. Yeah. Okay, then we said angular displacement, the unit is radians. Then we went on to discuss this guy, angular velocity, represented by that symbol. It's not W, it's that. It looks like W, but it's not. You write it like the way you see it. If those two guys facing each other, almost like W. Okay, angular velocity is angular displacement per unit time. second. Time. The unit for angular displacement is rads per second. Rads per second. You calculate angular velocity as displacement over time. Displacement over time. Your time in seconds. If your time is in minutes, you guys know how to convert to seconds. Okay? And I believe this is where we ended. Okay, so now everything is connected. The issue is for us to find the puzzle to how everything is connected, and we piece them together. All right. Then yesterday, when we discussed a radian, I gave us a value in degrees. How much one radian is in degrees? How much is one radian in degrees? 57.3 degrees. I gave it. Please do not forget. One revolution is equals to how many radians? Radians, not degrees. 2 pi. Right. Okay. Pi is just a number. When you press 2 pi and press equals, your calculator will give you the value of 2 pi radians. Okay. 360 is correct, but that is in degrees. So now, if you make more than one revolution, I can erase this. If you make more than one revolution, let's say you make a wheel turns 6 times, you've made 6 revolutions, right? One revolution is 2 pi. Another revolution is 2 pi. Another revolution is 2 pi. Right? Now you've made 6 revolutions. The angles you have covered, or the angular displacement you have covered, will be 2 pi times 6. 2 pi is just for one revolution. Now you've made 6. Whatever answer it gives you, that is your angular displacement after 6 revolutions. Okay, so in other words, we can calculate for angular displacement as 2 pi times the number of revolutions. We can calculate angular displacement as S over R. This one, we have not made a full circle with this one. We have just made part of the circle. Therefore, KG, you didn't tell them I'm here. You did not tell these guys I'm here. This one, let's see again. As I thought. Okay. So, this formula is only when you are having a distance, the arc length, this one that I've done on the zigzag, arc length. This is the radius. This one it gives you as a ratio. You're just comparing. You do a fraction of the arc length and the radius. You have not made a full circle. You only have figures. If it is 2 meters there, this guy is 2 meters, the radius is 2 meters, the arc length is 2 meters, what we have is 1 radian. Only distances. But with this one, you have made a revolution. And 1 revolution we know is what? Is 2 pi. You multiply by the number of revolutions. If you've made 12 revolutions, That's it. Okay. An example of why radians are easy to use. If this 6 revolutions, let's say it was a wheel of a car or a bicycle or whatever. This wheel of a car makes 6 revolutions on the ground to be rotating, I don't know, going in that direction. It rotates. The radius is 0.5 meter, 0.5 meters. After 6 revolutions, 2 pi times 6 is equals to what? 12 pi. Please use your calculators. 12 pi. This is a number, it's not just 12x or 12y. This is a number. It's not 12. It's 12 times 5. I don't know what it is. That is our angular displacement. You can press your calculator or change it to a number. Okay? Please work with your calculators. So this guy made 6 revolutions. It arrives somewhere here. That is where it is. Then they ask us, what is the movement from here up to there? How much distance has it moved on a flat surface, on a linear surface, horizontal line? We will go to this formula now. We have the angular displacement, 12 pi. We have the radius of the wheel. What we want is the what? The arc length, but it's not just only one arc length, one revolution, but it has been 6 revolutions, and this is what we have. The linear displacement. Linear displacement. Linear displacement is this on a flat surface. Your angular displacement is this time. How many angles you have made? Linear is on a horizontal, on a flat surface. We will take this guy. S is equals to theta times r. When you change the subject of the formula, you cross multiply. Your 12 pi times 0.5, you get, okay, give me in meters. Don't give me 6 pi, give me the whole value for, unfortunately it's taking us, still fine. Give me a figure. How much? 18, 849. So whether it was a bicycle, it was a car, after 6 revolutions it has covered 18.849 meters. I hope that's correct. Confirm with the calculators. Those that do not have calculators, at least you should have a phone that can calculate pi. Every phone now can do pi. Every phone has got a scientific mode of a calculator. At least you should do something. Are we fine? Are we together? Now, like I said, this angular displacement does not just happen in a flash. It happens during a period of time, which means if we have our angular displacement, we have time, we can calculate for the angular velocity, right? Okay, so in other words, if I combine this 2 pi n, I can calculate angular velocity as 2 pi n over t. Okay. With this 2 pi n, you have made more than one revolution. With this guy, if it was this, where you have not made a revolution, you can just use that. You have made more than one revolution, it's 2 pi a. If you have only made one revolution, it will just be times 1. Make sure your time is always in seconds. Time should always be in seconds. Are we together? So, yeah. I hope that makes sense. I hope that makes sense. Rotational frequency. Rotational frequency or rotational speed. It's the number of revolutions per second or per minute. Number of revolutions per unit time. How many revolutions spinning? Remember, whatever we'll be looking at has to do with rotation or anything that spins, that goes round. How many revolutions is it making in a second or in a minute? So this one they just count. For example, they give you we have a machine that can spin maybe 100 revs per minute. Which means in 1 minute, after you count 1 minute, it would have made 100 rotations, complete rotations. Okay? If they ask you, okay, if it can make 100 in 1 minute, then how many is it making in 1 second? Remember, a minute is made up of how many seconds? 60. If you divide this by 60, our answer will be now revs per second. 60 divided into 100 gives us how much? Okay. Divide. So which means in 1 second, this same machine that can do this is doing this in 1 second. 1 revolution and a 0.6 of a revolution in 1 second. In 2 seconds, it does double the amount. Okay, so converting revs per minute to revs per second, you divide by 60. Okay, revs per minute to revs per second, divide. Converting revs per minute per second, sorry, doing the reverse, second to revs per minute. You multiply. $60 is because 1 minute is equals to 60 seconds. This rotational speed, 100 revs per minute, is exactly the same rotational speed as 1.667, but per second. It's the same speed. Nothing is different, all the units are different. This one, for you to get 100 revs, you have to wait for 1 minute. But this one, every second that clicks, it has made 1.6. 6, 7. Any questions? Do not confuse rotational speed with angular velocity. Do not confuse them. This one is rads per second, radians per second. This one is revolutions per second, revolutions per minute. Are we fine? So this machine has made 100 revolutions in 1 minute. In 1 minute it makes 100 revolutions, which means in 1 minute it's angular displacement, right? This is angular displacement. Theta. Angular displacement in 1 minute, it means, I'll break that. It has made 2 pi for 1 revolution, isn't it? Times 100. Remember what we said? Times n. So if it has made 100, this will be 2 pi times 100. That will be how much angles it has made. Then we calculate the final answer. That is after 1 minute. If it is 1 second, which means it's 2 pi times n, 2 pi times 1.667. After every second, this is how much it is covering. Every second, this is how many angles it's making in radians. Your answer will be rads. Yeah. Even here, your answer is rads. Are we together? I hope you're not lost. This is your easiest topic, one of the easiest topics in N4. Everyone should get that. Now, we say this is in 1 minute. 1. This is in 1 second. Okay, so there is time involved, even as it is spinning 100 in 1 minute. There is time involved. This is what it gives us in 1 second, which means we can convert this or that guy to angular velocity. Angular velocity is equals to 2 pi m over time. That's what we said. You have that formula. 2 pi, how many revs are you making? 100, right? So we say times 100. What is the time? 1 minute. So you change it to seconds. 60. Whatever answer you give us will be rads per second. You have managed to convert this 100 revs per minute to rads per second. Stop. That's what you'll be doing. Please, by all means, let's know that. How to convert from revs per minute to radians per second. By all means, let's know that. Okay, so here are some pointers. If it is revs per minute, divide by 60. If you are given example number 2, 1.667 revs per second. We are converting this, but we know that these two are the same. The answer is going to be the same at the end. But I just want to show you that if it is revs per second, 2 pi n over t, 2 pi, the number of revolutions is 1.667 over the time. How much time do we have? 1 second. Okay. I like writing my seconds like that. But even if you just write S, it's fine. But I like writing like that. Your answer there, I'm sure it's the same answer. Because 16 to that's the 1.667 we are getting. Okay? So, my point is, if it is revs per second, this one is not doing any difference. This one here. Even if you do not divide, you just say 2 pi n. If this guy is in revs per second, you do not divide by anything, you are dividing by 1. If it is revs per second. But if it is revs per minute, you divide by 60. Any questions? I believe we're doing fine. If there are none, this is a 5.